So it is my pleasure to introduce Mr. Koteeswaran S., a highly experienced professional with over 34 years in the engineering and project management field. He holds a Bachelor of Science in Mathematics from Madras University, a Bachelor of Technology in Instrumentation Engineering from the prestigious Madras Institute of Technology, Anna University, and an MBA in Project Management from Alagappa University. Beginning his career in 1991 as a maintenance engineer at India Glycols Limited in the petrochemical industry, he transitioned after 10 years to become a control system integrator with Yokogawa, Singapore. Since 2011, he has been with Petrochemia, a petrochemical manufacturing plant in Saudi Arabia, owned by the Saudi Basic Industries Corporation. With a deep expertise in project management, system integration, quality systems, and instrument maintenance, he has led various projects from concept to commissioning. His skills extend to Lean Six Sigma Green Belt, reliability instrumented system, and SIL assessment, making him a valuable asset in the field of industrial engineering. Department of Instrumentation Engineering is honored to have Mr. Koteeswaran S., 40th batch of Instrumentation Department alumnus, available in online mode to deliver the first endowment lecture on role of instrumentation engineers in petrochemical industries. Welcome you, sir, and over to you, sir.
Am I audible?
Yes.
Maybe we can, yeah, thank you. It's a wonderful afternoon. Am I audible?
Oh, yes, sir.
Okay, thank you very much. Thank you very much, Dr. Lata, for this wonderful introduction. Indeed, Dr.S.RENGANATHAN, he was our dean when I just passed out in 1991. It's a wonderful time to be part of his own endowment lectures session. Professor K. Ravichandran, Dean, and Dr. Srinivasan, and Professor Manamali, and our own President Mita Sendilnathan, who is instrumental in organizing these events today. And my dear MITians, good afternoon. How are you today? Thank you. There was a thumbs up from Manamali. Thank you. There is an analysis says every day we make more than 36,000 decisions, consciously or unconsciously. But we do not know how many is correct. The same thing has happened with me in 1991, where I made a decision to join a petrochemical industry. And after a year, when I just completed GET, then the decision has come up, can we switch on? Then I decided to stay in a core business of instrumentation. Fortunate enough that even today, I could able to maintain that. So these kind of experience, I had an opportunity to just share with you. Of course, I will just quickly go through the presentations, then we can have our Q&A sessions at the end. Hopefully, roles of instrumentation. Can I share my screen?
So you can share, sir.
Yes, just send me. Is it visible?
Yeah, yes, sir.
Thank you very much. See, before getting into the roles of instrumentation, I'd like to have a few concepts what we generally discuss about, and before getting into the roles what's being played as an instrument engineers in petrochemical industries. Normally the word petrochemical, the petro is nothing but it's derived from the petroleum products. Just a quick check on the refinery. What happens is Normally we get a crude oil. Crude oil generally it's from either it's a deep sea or it's a desert or forest. From the crude oil, we have the refinery. This we call it as a onshore. In this, with the different kinds of process, we get a different kinds of products. Maybe it could be a fuel oil, lubricating oil, diesel, kerosene, aviation fuel, naphtha, petrol, or refinery gas. So like this, there are multiple products are coming. In that, there are two products which is basically an input for a chemical industry. That we call it as a naphtha, and of course the gas, the fuel gas what we have. So generally what happens when this naphtha comes into the industry or the natural gas. So here broadly there are three kinds of chemical industry basically is there. One is synthetic gas, olefins and aromatics. So when the crude oil comes in and from the naphtha, what they do is they do the steam cracking. So the steam cracking is a very, very interesting process. What happens is in the naphtha, it's being sent to the pipelines inside the furnace with high temperature. So what happens with the high temperature? It cracks into it's a smaller molecules. That cracking happens in millisecond. That's what we call it as the cracking is a very, very specialized process and happens in milliseconds. So depends on the cracking and design of it. When you talk about aromatics, it's a benzene, toluene, xylene. And when you talk about olefins, ethylene, propylene, butadiene. Synthetic gas, methanol, and ammonia. So right now, I am working in olefins. This is center of one. Ethylene, propylene, and butadiene. From there a lot of products are being made like polyethylene, polystyrene, polyvinyl chloride, PVC. These are all like plastics. Okay, from aromatics, what we get it dyes and synthetics, plastics, synthetic fibers. From synthetic gas synthesis, methanol, ammonia. Normally we call it as an urea. That is a fertilizer plant. So these are all the main tree from the petrochemical industry, or you can say these kinds of almost 10 products from the petrochemical industry using those naphtha and the gas, natural gas, plastics, fuels, chemicals and solvents, fertilizers, synthetic rubber, packing materials, adhesives, synthetic fibers, pharmaceuticals, cosmetics and personal care products. So these are all made in a different kinds of petrochemical environments. Now, when we talk about petrochemical in Jubail industry, this is just a Wikipedia information. This is one of the largest petrochemical city in the world. You can imagine that this is more than 1,000 square kilometer. The industrial complexes, the multiple industrial complexes are there. It itself is generating a 70% of GDP for the Saudi Arabia, one of the biggest industrial complex. So when you talk about petrochemicals and what is the difference between why we call it as a petrochemical, why it is so important when we're talking about the instrument and control system. See, in general, what happens is whenever the refinery or the petrochemicals, we call it as a hydrocarbon. That means the hydrocarbon is nothing but there's a carbon and hydrogen is present in this raw material or the product. So what happens when you say hydrocarbon? It's highly flammable and highly dangerous to handle it. So for those things, you need to have specialized skills or knowledge about those process and the hazards which is involved into that. So now what we are seeing in front of you is a simple system architecture which is being utilized in general, all the industries, even it is applicable for the refinery and all the industries it will be there. So first step is like this we call it as, so this basically, these are all the field instruments where we can talk about this is a primary sensors which converts that one form of energy to another form, it transmits the signal to the control room. So basically this level 0 we call it as a field instruments. Could be different communications protocols will be used. All these communications are converted into a digital form. If it is a 4 to 20, it is converted into a digital form. Those digital forms, we have a controllers, which we call it as a DCS, distributed control system, where you execute the algorithms. Where there is a safety interlock, the safety point of view, we have an emergency shutdown system or programmable logic controllers. So these things are the logic executions happening there. This is level 1. And above this, so these are all the controllers. How do we access the controller? How do we see the controllers? How it's being operated? Plant is being operated. That we call it as a supervisory level 2. That's where the operator is being accessed, and even the engineering activities, operations, the informations, or historian data, everything goes into the level 2. So that stays up to the plant level. Now, what if the requirement goes beyond that? Might be the administrative purpose, the information is being shared among the executives, then it comes as a site manufacturing operation. That means it goes to the level 3 and 4. Sometimes even it travels beyond the city, beyond the country, it's globally connected to the different places. Then it's called the level 5 enterprise business plan. So the threat, what is happening here, when it goes beyond the control limits of the plant, then it needs to be protected from, they would call it as like a firewalls, so that nothing is being penetrated from outside. So this is a very, very basic system architecture. It goes with any kind of plant. So basically we have field devices. This is the controllers or the PLCs. We say this is a supervisory level, so how it's being accessed. This is all HMI, human machine interface. And this is a supervisory level or the higher level network information sharing, and even can travel beyond the network. So this is a basic architecture. In this, what is the play of instrumentation? What is our role? This is a question. This always we need to keep it in mind. We call it as a RAM design. It's applicable for any kind of equipments or manufacturing. Even it is applicable even for our own personal life. RAM. Reliability, availability, maintainability. That means whatever the instrumentation is being used or deployed to control the plant, the first question is it reliable? What's the reliability means? It's a probability of an asset will perform the intended function for a specified period of time under specified conditions. Or you can say in simple words, whenever we buy a product, we go and see what is this warranty and guarantee. This is what it is. That means without any failure for specified period, the instrument asset supposed to work. That's called reliability. Availability is the probability that asset in an operational condition at a given time. That means reliability is over a period of time. When I say availability, that particular time when it demands, it's supposed to work. That's where the asset is availability. Maintainability is a real challenging where all the engineers being deployed. That means it needs to be a maintainable. That means the measures has to be taken from, we say, the design to the commissioning part, and also it has to be maintained. Design, installation, manufacture product to reduce the required maintenance, man-hours, tools, logics, skill set, facilities, everything comes under the maintainability. When you talk about maintainability, that becomes a very big challenge for each and every equipment that's being used in any kind of industry. So when we have this concept of RAM, that means wherever we go in any kind of industries, especially refinery, petrochemical, nuclear, anywhere in the plant, this RAM is the one which works for an instrument engineers. Reliability, availability, and maintainability. So to enhance it further, how we are going to have those asset management plan? It almost having 6 kind of steps. One is identify and categorize your asset. It could be with respect to the application. It could be with respect to the area it's being used. It could be an hazardous area, safe area. When you talk about applications, it could be for an acid, gas, water, steam. So let us categorize the importance of the asset. Number 1. Number 2, and what is its performance? How we are going to monitor this performance? with respect to the category. So maybe sometimes we say that key performance indicators. We define a key performance indicator to monitor the conditions and performance of it. Then asset life cycle management and the replacement cycle, because every asset has its own life. So with respect to that one, we need to, when we talk about failures, why we need to have that replacement, why we need to have a life cycle assessment is nothing but we need to study those failure rate. Normally when you're talking about reliability on the failure,
Yes, sir. So audio is not available, sir.
Looks like a technical glitch.
Oh,
Let's wait for a few minutes.
oh.
Senior, you got disconnected. You are muted. Can you unmute and speak? Koteeswaran Senior, please unmute yourself.
Screen.
Sir, screen, sir.
You are not audible.
Sir, you are in mute,
No.
sir.
We can't hear you and screen share has gone.
now I'm audible. I don't know,
Yes,
something.
share screen again. Please.
Technology challenges. Let me share it once again.
We are used to this.
Oh, thank you for the understanding. Basically.
COVID times.
Yes. Screen is available now.
It's coming up.
Okay.
Yes.
Yeah, correct. So basically, this is what we are just talking about. The asset life cycle management is nothing but we are talking about the obsolescence and asset disposable, and also you need to find the replacement options. And the last one is talking about asset management software, because sometimes whatever we are studying in the industries or during our degree, those being converted in terms of a software to do the failure analysis, to calculate the mean time between failure. These are the terms what we use it. There are softwares that are available which we use to determine the strategy and also to determine the asset life cycle, and we just plan for it. So this is a whole plan. So very in simple terms, when you talk about any kind of industry, this is what happens. That asset becomes our main focus, and we need to have this complete management program for those assets. Now, it cannot be played by an engineer. So different kinds of discipline, they just segregate different kinds of industry. They name it in a different way. What generally we are just naming it. Just let me share those things. In general, if I just ask, there are 5 places where our instrument and control system engineers are playing the role. That means, one is the project. The project starts from engineering, procurement, construction, and commissioning. Second is the maintenance engineer, control system engineer, asset and asset management engineer, asset engineering, finally the cyber security. So this is the 5 areas where our control system engineers are like serving in a petrochemical industry. So let's quickly just go through one by one. It's a project engineer, that is engineering, procurement, and construction. The word itself gives us what is the skill set which is required for us. Engineering. Suppose when you want to do the engineering, now when there is an instruction going with Dr.S.RENGANATHan, some terms were used, ISA, IEEE. So these are all the associations where they develop standards. Suppose when we talked about also the hydrocarbon industries, when hydrocarbon is highly flammable, explosive. So those, whenever we use that word explosive, why it is so critical is, it very in general, when you have the fire triangle, we need to have 3 arms. One is the fuel, second is the oxygen, the third is the engineering source, where explosion or fire can happen. So this is what the main role, whenever we talk about hydrocarbon and the refinery, it's all highly flammable. This is the 3 things how we are going to control. Because we cannot avoid the hazard. Hazard is going to present there. The point is how you are going to control. Fuel is there already. Oxygen is already there. So only the point of consideration is the ignition source. That's most important. Even it's a small amount of joules, the energy is good enough to ignite the whole the environment, hydrocarbons. So what happens is even those design of instruments. For example, you take a flow transmitter. So flow is being measured. It could be any kind of measurement. That, for an example, like you say orifice, there's a DP, that measured, that mechanical energy needs to be converted to the electrical energy. So it needs a transmitter, which converts this pressure into the electric signal, and it's being transmitted. So when there is a conversion, electronics involved, that electronics is installed at the field. So that's where what kind of hazardous measures we are going to take. Could be electronics are kept inside the explosion-proof junction box, or energy limit is happening from, that's what we call is intrinsically safe, that is happening from the control room. So these are all what type of industries and what type of standards, everything is available. So as an engineer, we need to prepare those specifications for this. Definitely, we need to have experiences of the standards. Then after that, there is awareness. We need to have the vendor evaluation. Suppose who is going to be there, how you are going to evaluate the vendor, what products is available where. So those studies also we need to do. Then all those requirements with respect to the process requirement, engineering documents are to be prepared, and you will be just placing the orders, evaluations, inspections, bringing it to the site. As for the drawings, engineering drawings, it has to be constructed, commissioned, and just that becomes the complete project handover. That is site acceptance test, SAT. So this is the role of an engineer. In petrochemical also, why there's EPC, in general it is a separate entity, but in petrochemicals, when they do the debottlenecking or when they add some kind of units, then all these jobs are done by instrument engineers. So next role, what you're talking about, maintenance engineer. This is very interesting. Might be you will be having an opportunity to have a field visit. You can visit the industries where you can visualize, see when you talk about pressure transmitter or the temperature transmitters. In general, we'll be talking about the bottom tube, bellow, RTD, thermostat, thermocouple. We do the principles, but when we go to the industries, it's being built in a different way. So normally we'll be having a field visits to identify and see, or some kind of manufacturers also we normally visit when during our studies. So when maintenance engineer, that's where one thing is sure, always we need to remember, we are with the assets and also we are with the hazard. That means safety becomes a primary culture. You know, when you talk of, this is where, when you say the experienced people, the people who worked in refinery, the people who are having experience in petrochemicals are being treated, nuclear is being treated like a top rank, because always hazard is present. That means safety becomes a prime culture for them. So each and every job, whatever we do, it has to be done with the keeping safety in mind. And second thing, as an engineer, we give a technical support to the technicians, That means we need to have a good amount of knowledge about the field instrumentation, what is the principle, how it's being evoked, and what all the there is nowadays coming up with a lot of configurations. So this is all the knowledge we need to have, and engineers who support those field technicians, each and everything. Now there is always in industry, experience doesn't matter. Always we need to follow procedure. That means whatever we do, we write. Whatever we write, we follow. That's a principle of whatever the industries we follow. So each and every step is being written. Just we need to follow those steps. When anything goes wrong, definitely we need to have a failure analysis, root cause analysis. Then could be any changes needs to be recorded. There's a mechanism of change. Whatever it's a design variations need to be evaluated. Hazardous situations, risk assessment to be conducted. And when you're talking about, just now I was referring about the maintenances, like shutdowns or emergency shutdowns, or some plants may be going for a planned shutdown every 4 years. Those scopes, the budget, it becomes a responsibility of maintenance engineer. Cost optimization. So it's not only just doing the maintenance, and also we need to be cost effective. So when you want to become a cost effective, you need to have very good analytical skills or troubleshooting skills, because otherwise simply without troubleshooting, maybe a lot of spares might be consumed, and also like that is going to cost more. So we need to be like a cost effective also. Other than that, spares are being procured, new instruments are being procured. The same way those engineering concepts are coming in, the technical specifications, evaluations, inspections are part of the engineer scope. In addition to this, obviously, there's a knowledge sharing. By sharing, we also like gaining more knowledge. That's a belief there. And whenever there is a debottlenecking, additional projects coming in, the changes coming in, that becomes a maintenance engineer responsibility. So basically, he takes care of the field, complete field instrumentation. That becomes a maintenance engineer. Then control system engineer. It's really a very, very interesting one. So what is the difference between maintenance engineer and the control system engineer? Almost everything is similar. That means control system is also like need to be safety is on the top priority. Everything, the development of maintenance procedure related to the control system, failure analysis, cost development, cost optimization, turnaround maintenance, everything is similar to field engineers, except the maintenance engineer. Difference is system related activities. Limited to is the systems, configuration, administration, and backups. When you talk about system, the scope is very big, because you have distributed control system, that is DCS we call it as, PLC, programmable logic control system, emergency shutdown systems, SCADA systems, you have a third-party communications. Each system is a variety of systems are there. Now, how we are going to manage is a very big question. In general, that's why you prefer experienced people as a control system engineer who worked with the systems previously. For an example, if I have Ikugawa systems, we prefer to have a Ikugawa engineer part of our team. Or we need to train the personnel whoever is available with us. This goes in two different ways. And this really is challenging to keep up. What are the latest updates of those control system happening around? What is the latest out of technology? Those they need to keep themselves updated, and whatever the troubleshooting comes in, configurations, the changes need to be part of this. And there are two kinds of control system engineer. It's really tough role compared with two kinds of requirements are there. One is when you have a continuous plan. For an example, olefins when you talk about, it's a continuous plan. If you talk about boilers, it's a continuous plan. Why? The control loops, the strategy, the algorithms are standard. These are all defined. It runs. Once it is just tuned, it gives its performances. Whereas batch process, for an example, like when you're talking about, especially when you have like plastics are being made, polyethylene, PVC, polystyrene, this goes in batches. When it goes in batches, the batch software is written. It might be used like a 50 different set of the sequences. Each sequence has got controlling different kinds of inputs and outputs. Those batch scripts are really a challenging one, and if anything, like troubleshooting is also needs very special skill. So here the control system engineers have been more respected when it goes to the software point of view, the troubleshooting when it comes into the line. So this control system engineer, we call it as a safety integrated system. That is all talking about logic execution. Other one is the control algorithm execution. This is really an interesting area where control system engineers can play. You might be aware of like when you're talking about DCS, Ikugawa, Honeywell systems, Emerson, and in Foxborough, these are all the ABB, these are all some DCS vendors which are on the globe. And when you talk about PLCs, we have Siemens, Allen Bradley, Triconix, the Invensys, we have a lot of other field for the ESG systems. And third parties, nowadays each and every systems are built in with a lot of diagnostics. For example, even if you have electrical systems, they're all built up with the diagnostics to have before what we call as a proactive maintenance, to diagnose and take a proactive job so that you can avoid those kind of random failures or avoid unpredicted shutdowns on the unit shutdowns. So this is a very interesting role as a control system engineer. Now both what we talked about, what we discussed, maintenance engineer and control system engineer, they are all related to the asset, the whole asset of the life cycle, everything is being done. But asset engineering and performance, they are the engineers who can globally see the overall picture of the whole asset. Means the strategy development. The strategy development is not so simple job. So to have a strategy development, one is as such, what is the reliability figures maintained during the design level from the vendors, and also the usages, and to develop a strategy. So to develop a strategy, the tools are being used. RCM, that is reliability central maintenance, and the RAS, that's what we're talking about, the SIL assessment, that is reliability instrumented system. So these are all the tools. To use these tools, definitely needs amount of training and also the experienced people deployed in the asset engineering performance. Now we talked about asset life cycle assessment, that is the obsolescence. That itself, it's going to be very interesting. It needs a lot of knowledge. Let me just give a small introduction. What is the asset life cycle assessment means? Suppose a product, it starts from there. How many years it's being supported by the vendor and the spares are available. There is a point where the production will be withdrawn by the vendor only if the spare support will be there. There is a point of time the spares will be stopped, only the repairs will be there. There is a point of time where they're completely withdrawn.
So audio is not available. Sir?
When you say assurance program, that becomes asset engineering responsibility. That means from the design to the execution part, is it being done as for the intended purpose? So that basically you can say the audit, internal or external audits, standards compliance. So when just a simple example, we talked about exposure profiling, by it, how it's being complied or not. So that becomes asset engineering engineer's responsibility. And the overall asset performances, key performance indicators are there. In case of chronic failures, repeated failures, it becomes a responsibility that we need to avoid the reoccurrence of it and also try to take a proactive measures to predict these failures and take the measures in advance. Obviously, all the projects, because the engineering package development goes with asset engineering and the performance team, finally the knowledge sharing comes. In asset engineering and performance, generally the team will be having a much higher experiences, and also they know about those how to use the tools and to develop a strategy and do the failure analysis. So this is the very challenging role as an asset engineering and performance management. And also a lot of certification programs are available. When you're talking about SIL level, that's TUV is a company who gives a training how to do the SIL assessment, and even being trained in certificate, even reliability center maintenance, how to do the failure analysis. There's a lot of courses available there. Will become a certified engineers to perform those tasks. Even a lot of people, even in the later part of their life, they even take it as a freelancer to once they have the knowledge, they can offer a lot of freelancing jobs. Even in the inspection, if you know the standards, you can be an inspector into this. So you can have independent activities also with respect to this asset engineering performance. So last question is like cybersecurity. Of course, Mr. Morgan will be touching it in detail. I'll just give a brief idea. Now, when you start seeing those kind of revolution happened in control systems, when you say in the 80s, we normally had, that's where the 80s and 90s where the computer is being launched into the, so those areas, the systems are all customized display, customized floppies. You won't believe nowadays we are all with the USBs, all those things. We worked on 21-inch big floppy disk. Can you imagine 21-inch? That's where the storage mechanism we used. Then it has been turned into the 2.5-inch. Then it becomes like a tape. Then it's being transferred into the USBs. The technologies keep moving. So in that case, what has happened is, even as a manufacturer, they start challenging the system in this. Everything has become costly now, and meanwhile, the computer is also getting like window-based. It was very popular in the market. So we started challenging the DCS vendors. Why can't we build up an open system architecture instead of creating a monopoly on those supervisory level machines? Then they started building up the open system architecture. That's why the normal PC, what we use, is also used in the industries. So it has got its own challenges. What is the challenges? Because when you have the open system architecture, that we don't have any control, because those window-based machines, that migration changes, upgrades, so very fast. Now, as that's another challenge as a control system engineer. He has to cope up with the changes happening in the market. So and also it brings its own threats. What's happening from there? So whatever you're talking about, the virus, malwares, everything is, there is every possibility that it might be penetrating into the control layers. When it comes to the control layers, of course you can imagine that the whole plant control goes to the opponent party. So what's the threat into this? That means they can control the plant, or they can, the way it's all explosive material, it's a flammable one. So they can do whatever they want. You can imagine what kind of the impact it may create. That's why it becomes very necessary that the cybersecurity nowadays is being deployed into the control systems also, even with respect to the emergency shutdown systems, with respect to the control systems. Now, even what you talk about ISA, they started developing the standards, and each and every, even the government bodies, they started deploying it. So there's antivirus systems, network firewalls, network switches, routers, security informations. This is the engineer responsibility. He creates a security management program. So he deploys the security upgrades. This is a continuous one. And also for asset lifecycle management for control systems. Finally, he is all responsible for the latest upgrades of those cybersecurity, how it is being done effectively. Might be Mr. Mohan will be covering in his presentation. So these are all the areas which has been part of it. Let me have a quick just a summary before we get into the QA sessions. Basically, whenever there is asset, whenever you say asset, this is a RAM model, we say reliability, availability, maintainability. This is a question is being asked, why it has happened, how can we prevent the reoccurrence, and can we avoid? This is the questions repeatedly being asked. To get an answer is not so easy. For getting those answers, this is the model we need to have all these 6 areas. It's a whole management program, asset management program. We need to come up with it. And there's a different roles are being, interest roles are being played by a control system engineer, project engineer, maintenance engineer, control system engineer, asset engineering, and performance management engineer, cybersecurity. Now, this is what the question is being asked. Are we covered during our profession? The answer is yes. A lot of things we will be doing, the principles. When you go to the industry, when you see it, so those we can recollect those things. See, whenever we rarely talked about, like when in industry, you can say, when you have the performance tuning, PAD values, you are just running it through either closed loop or the open loop, or running the Laplace transform, you'll be finding a PAD values. This is all happening in algorithm. It's already designed and runs. You can see those things, just tuning it, and you can see the performances. You can live performance, whatever just theoretical part. Yes, we get an opportunity to match it practically. So there are interesting roles out there, and when you talk about those, the controls, that's a different one. And each and everything we can just talk in a different way. So basically, I wish control instrument and control system plays a very, very major role in petrochemical industries. But it's not only we talk about take care of risk the hazardous area, but also it talks about the reliability, and also it is a main layer of protection for any kind of the hazardous situations, the consequences. So to avoid the high consequences, these are all the layers are being built and need to be maintained. That becomes a major responsibility for the instrument and control system engineer. Now with this, I hope I can just have QA sessions. Maybe I can just stop the presentation. Maybe any open questions, that's fine.
Sir, only one question I am having here. As being an instrumentation engineer, because lifelong learning is common for everyone, we have to keep on learning.
See, normally we say no. If you don't have questions, only 2 things can happen. One is 100% understood, other one is?
Sir, a question from my side, Srinivasan.
Yeah, thank you, sir. Please, go ahead.
Sir, because as lifelong learning is common for everyone. Whoever's there in the profession, they have to keep on learning. Being an instrumentation engineer, what we have to keep on learning, what could be the, because a lot of certificate courses are also available, what could be the best one so that being in an industry so that they can learn it and they can excel?
Okay, sir. See, actually now, this is really a challenging question. Actually. Why? Nowadays, when you start the career, that's one of the big challenges where we are getting in. When you talk about instrumentation, one is you have sales, marketing, and industries, and a lot of people, they are migrating to core business, they are getting into the IT. So basically, where we are getting in, it depends on. Suppose when you stay in the maintenance, as a maintenance engineer, So I moved from maintenance to control, control to asset engineer. So when you are moving it, then it becomes a requirement. And also, when we stay in an organization, suppose when I'm just in the petrochemical industry, I'm holding the responsibility. There is an assessment is done every year. What is the requirement we need to enhance? We do a lot of certification courses with respect to the role what we play. So when I am in the maintenance engineer, I need to aware more of the field instrumentation, the basic knowledge. So I'll be having a training session for those field instrumentation. When I'm being just moved into the control system engineer, then I need to have awareness of particular system. I can have a generic one, but I need to have a particular training session for that particular system, what's being handled, because it could be a different kind of configuration altogether, different kind of setup. When it comes to the asset, there's a different roles we need to play. Now the question comes, where we are going to stay. This is the biggest challenge nowadays, what we are having. Suppose someone is in those who are going to be in sales, or someone likes the marketing, that is also good. They may go with a management concept. They become a more techno-commercial or viable engineer when they have the technical knowledge also. So now to start with, so these are all the industries where we are targeting. Now, first of all, nowadays, in my opinion, the students are very smart where they need to choose the field. They are when you talk about the course, it gives a broad spectrum of each and every aspects of what's being industries are there. So during maybe the 4th year, when they are coming for a campus interview or this, it's better to focus somewhere, or they can start with the industry. Always industries are nowadays industries are going up it's growing very fast, because before the COVID, a lot of projects are being suspended. Nowadays the projects are going to come up. A lot of industries are being built. So now the projects are coming up. So either they can go with the engineering one. If you want to become an EPC, engineering EPC, you want to be part of it, please have a theoretical knowledge. Whatever you study, let keep us ourselves. And ISA membership or IEEE membership will help us to study those standards. Those who are targeting an EPC, they can become a member, they can analyze the standards, they can understand the standards. The maintenance
Hello. Sir, not audible, sir.
Okay, now it's okay. Am I audible now?
Yes, sir. Now audible, sir. So now audible, sir.
Audible. Okay.
Sir, you're audible, sir.
Okay, I'm in a different device because my laptop is having a problem. So basically, that is the answer, sir. Basically, which field we are going to choose. Normally, go to the IT is going to be highly challenging, because that's a very vast field to do. When you go for so the stable job, or you can planned way of moving the life is from the refinery. Whether it could be an offshore, or it could be an so it could be an offshore, or it could be petrochemicals. You can go for it. If you want to rank it, it goes like this: offshore, number 1; refinery, number 2; petrochemicals, number 3. In that, steel, cement, paper industries, this comes to next. Pharmaceutical, it comes next. So when you want to choose as a maintenance, so if you want to hit at the biggest one, refinery and petrochemical, you can have a very good start. And if you are moving to manufacturing, like control valve, transmitters, like you're talking about the immersion, it is having a margin of sales, marketing, and manufacturing. That is a shop floor. That we can say. These are all mainly a white collar job, you can say that. The control systems, DCS, manufacturing became a white collar job. In IT, that's really a volatile market. It can have a very big oscillations there. So why our one progress is not exponential, but it was a very steady for last 30-35 years, and now the industries are going to grow up. So there are a lot of projects now itself is coming up. You can see that a lot of projects are coming up now in the different countries. The whole world is going to. So maintenance, EPC, manufacturing, 3. IT, that's would be a tricky one. Thank you.
Sir, thanks a lot, sir. I think you have just given us in a nutshell that what could be the different roles which we can able to have it. I think the students will have a very good idea that in which way they can able to have. And thanks a lot for your nice presentation. And